Hello all, this is Mr. G, and in today's video we're going to be going over how to do the problems from our review for Chapter 3, Sections 1, 2, and 3. Let's jump right in. In number 1, all we have to do is classify the system as either independent, dependent, or inconsistent. And to do that, we need to figure out the m and b values, the slope and y-intercepts, which means for each one of these equations, y has to be by itself. Let's start with the first one. Y is not yet by itself, so let's rewrite this down here. We got to get rid of the 2x, and we have to get rid of the 3. First, we cancel out the 2x by subtracting. Then that will give us 3y equals negative 2x plus 7. Then divide by 3. Divide both terms on the right side by 3. And we end up with y equals, that's just going to be negative 2/3 x plus, I'm just going to leave that as 7 over 3. Now, that would be really annoying to graph, but remember, we don't have to graph this. All we need to do is classify it. So we're just going to leave it as fractions for now. Now let's do the red. So let's see. This is going to be 5x plus 15y. So let me write that down here. 5x plus 15y. I already forget the rest of it. Equals 35 minus 5x. Equals 35 minus 5x. Let's double check that one more time. Make sure I didn't miswrite it and screw up the whole problem. Looks good to me. Okay. Here we've got some more work to do. We've got to get the x's together, or rather, we want the y's by itself. So let's combine those like terms, subtract 5x from both sides. And at the same time, I'm going to rewrite the right side so it's closer to mx plus b. So we know this is going to be a negative 10x right there. Let's put that in front. So let's make this negative 10x plus 35. Then we're going to divide by 15, divide both terms on the right, just trying to get y by itself, remember. Ooh, let's see. We can simplify these fractions. The first fraction, negative 10 over 15, we can divide both of them by 5. That's negative 2 over 3x. Plus, here we can divide by 5 again, right? So that would be 7 over 3, if I'm not mistaken. Now we just have to compare our two equations. So this equation and the other one, which was in green right there. So looking at this, first we check the slopes. I see a slope of negative 2/3 and negative 2/3. Same slope means it could either be right on top of each other or parallel. So we have to check our y-intercept, and the y-intercept is the same. That means these lines are coinciding. They're essentially the same line, which means they will be dependent, which hopefully is the answer right there. Yes, dependent. So we know we got it correct. Okay, number 1 down. Number 2, same directions. Got to get y by itself. Again, we'll color code this. We'll do the first in green. So let's rewrite it. Y equals 1/2 times x minus 12. Y is actually already by itself. We just have to distribute the 1/2, and we get y equals 1/2 x minus 6. So first one down. Second one, we'll do in red. This is going to be 2x minus y equals 6. Slightly more work to do here. We have to get rid of the 2x and the negative in front of the y. Let's subtract 2x first. That gives us y equals negative 2x plus 6. Oh, forgot the negative there in front of the y. That would have been bad. Now we divide by negative 1 to all terms on the right side and get y equals positive 2x minus 6. Now we just have to compare this equation to, where was the other one? Right there. First thing we do is we check our slopes. And the slopes are different, which means they're going two different directions. Remember, slope controls the direction the lines go. And if the lines are going two different directions, I don't even care what the b is going to be. We know they're going to be intersecting once because they're going two different directions. So that means it should be independent, which that's the answer. So 2 down. I forget how many to go. Let's just keep going. Let's take a look at number 3. So same directions. We just have to classify. We'll start with the green. So it's 4x plus 5y equals 20. And get y by itself. Take away 4x from both sides. And we get 5y equals negative 4x plus 20. Then divide by 5. Everything on the right gets divided by 5. We end up with y equals, we'll leave that as a fraction, negative 4 over 5x plus 4. All right, now we've got to do the red, which is this one right here. Let's see, it's 6x plus 15 over 2y. Let's write that one first. 6x plus 15 over 2y equals, I forget the number, equals 18. Okay, getting y by itself here. So we'll subtract 6x. And we get 15 over 2y equals a negative 6x plus 18. Now, we could do this two ways. To get rid of this 15 over 2, we could do it in 2 steps. We could multiply by 2, and then on the next step divide by 15, but I think it's going to be faster to just multiply by the reciprocal, 2 over 15. Essentially, we're doing those 2 steps at the same time. We're multiplying by 2 and then dividing by 15. So let's see what happens here. On the left side, we just get y equals, then we distribute this to the negative 6x and the 18. So let's think negative 6 times 2, that would be negative 12 over 15. But we can simplify that. We just divide them both by 3 and get 4 over 5. So negative 4 over 5x. And then distribute it to the 18. Let's see, if we double 18, that's 36 over 15. We could divide both of those by 3, but tell you what, we might not even care about the b value. Let's see if we even need it. Let's compare our, that's not what I wanted. Okay, here we go. Let's compare our slopes first. Oh, we do have the same slope. We've got a negative 4 over 5 and a negative 4 over 5. So the b value, excuse me, actually does matter. So let's simplify this. 36 divided by 15, we can divide them both by 3. That becomes 12 over 5, if I'm not mistaken. 12 over 5. Okay. So that is not going to be the same b value. We've got a b value of 4 and a b value of 12 over 5. So the lines are going the same direction, but they're not on top of each other. They're missing each other, which means they're parallel, which means there's going to be no solution. So our answer is inconsistent. All right, moving on to number 4. Finally, a change of directions. Not classifying anymore. Now we have to solve each system of equations. Now, I don't care whether you use substitution or elimination. Actually, the first thing I'm going to do is try and figure out which one would be best. For this problem, I'm probably going to use elimination. This left side is almost lined up with the x's and y's. Let's line it up. I tell you what, let's try and keep this somewhat organized. Let's keep it color coded. So the green one, I'm going to leave the same. I'm going to leave it as 5x minus y equals 12. But the second one, the red, I'm going to flip the order. And I'm going to make it 2x plus 3y equals 32. Just to make sure our x's and y's are vertically lined up. Now, before we can eliminate, we need to make sure we have opposite coefficients, the same number with the different signs. I'm going to try and cancel out the y's, because to do that, we can just try and turn this negative y into a negative 3, so it'll cancel out with the positive 3y. So to do that, we would just multiply this by a 3. So let's see, the green would then become, distribute this, it becomes 15x. Let me be careful with my multiplication. Minus 3y equals 36. And the red doesn't change at all. It's 2x plus 3y equals 32. And now we are ready to eliminate. As soon as we see the opposite coefficients, we can just combine and cancel out one variable. So we get 17x. We could put like a plus 0y here, but we don't need that. We know the y's cancel out. Equals 68. And 17, well, we got to divide 68 by 17. I'm going to do this in my head real quick. 68 divided by 17. And we got 4. Done in my head with no help at all. You all saw me. So we get x equals 4. So one of our answers is done. Now we just have to take this value and plug it in for x in any one of our equations. So let's scroll back up, look at the equations. Let me draw a line here just to keep this work separated. I don't think it matters whether we're going to use the originals or one of the ones we created, like after we multiplied. Either one is fine here. I'll probably plug into, I guess the first one. It doesn't really make a difference. So this becomes 5 times x was 4, right? Let me scroll down just to double check that. I don't want to screw that up. Yeah, x equals 4. So it's 5 times 4 minus y equals 12. Now we just run through the algebra. 5 times 4 is 20, minus y equals 12. Take away 20 on both sides. We get negative y equals a negative 8. Divide by the negative 1. I guess you could also multiply by negative 1 if you really wanted to. And we get y equals a positive 8. So x equals 4, y equals 8. Let's double check that answer. Yep, that's the answer. X equals 4 and y equals 8. All right, number 5. Same directions, got to solve. First thing we have to figure out is substitution or elimination. What do I think here? This y is almost by itself. That kind of makes me want to use substitution here. I think I'm going to use substitution. But before I do that, I'm gonna let's mark these. So that's green and red. I'm gonna do some work with the green one to make it somewhat easier to work with. I don't like that 1/2. So tell you what, let's multiply all this by 2. So then the first equation becomes 2y plus x equals 2x plus double 16 is 32. And then let's get the x's together. So let's just subtract x. Again, you don't need to do all these steps. I think it's going to make the substitution easier though. So 2x minus x is x plus 32. All right, now let's use the red. So here, we just have a negative in front of the y. That's really the only thing in our way. Let's divide everything by -1. And then, tell you what, let me just put this right here. So this becomes a positive y equals -5x minus 6. And now that we have this y by itself, we're ready to substitute. Of course, it all disappears. It was -6, right? Yeah, very good. So I can take what y equals, this -5x minus 6, and substitute it in for, oh, not for x, that was a mistake, in for y in the other equation. And that's exactly what we do. So this becomes 2 times, and it's -5x minus 6, substituting that in for y, equals x plus 32. Now we've got an equation with just one variable. The algebra looks a little messy here, but we can handle this. Distribute the positive 2, get -10x minus 12 equals x plus 32. Nothing changes on the right side. Then here, let's see. Let's combine like terms. Let's add 10x to get a positive coefficient of x. And at the same time, let's subtract 32. I think we can handle that. So this becomes a -44. Am I doing that correctly? I think I am. Equals 11x. Then we divide by 11. And we get x equals, don't need that there. X equals, what is that? Just -4? So x equals -4. One answer down. Now, just like before, we have to take that x and plug it into one of our equations. Which equation looks easiest? I'm actually probably going to use not one of our originals. I think I'm going to use, let's circle this in black. I think I'm going to use this one. I think that'll be the easiest one to plug in x. So, let's do this in blue, I suppose. This equation now becomes y equals -5 times, it was -4, right? -4, very good. Minus 6. And then we just simplify, essentially. So y equals -5 times -4 is positive 20. Take away 6, y equals 14, which is hopefully the answer that's on the answer key. So we got -4 and 14. Let's double check ourselves. -4 and 14. Okay, so far, so good. Moving right along. Number 6. Still solving. Let me see. This looks like another substitution problem to me. Yeah, I think I'm going to substitute here. You can use elimination, but like I'm looking at this, to get, I think it'd be easiest to get x by itself because all we have to do is move that y in that first equation, which will make the green like we've been doing it the whole time. Just move that -y, and then x will be by itself. So let's add y on both sides. So then the green equation becomes x equals 3y plus 9. And then we don't actually need to do anything with the red equation. We don't need to change it. We're just going to take what x equals, which is 3y plus 9, and plug it in for that x. So then the second equation, the red equation, will turn into 12y equals 4, parentheses, what x equals, which is 3y plus 9, plus 12. Then let's see, distribute here. So we get 12y equals 12y plus 36, if I'm doing that correct in my head, plus 12. Oh, I see a problem because we have to combine these like terms. And when we subtract, it cancels out on both sides. So we end up with 0 on the left side, and on the right side, we get 48. So the variables disappeared, and we end up with something, two numbers, two values that are not equal. When the, how do I want to say this? Remember, when the variables disappear, it's either no solutions or infinitely many solutions. And since 0 does not equal 48, we say no solutions. It would have been infinitely many solutions if we got like 0 equals 0 or 48 equals 48. But since the two numbers are not equal, we say no solution and we move on with our lives. Let's take a look at number 7. So number 7, we've got to graph the solution of each system of inequality. So here we actually have to graph. So first thing we need to figure out is, are we dealing with lines or are we dealing with v's? Both of these are going to be lines because they're not absolute value, which means essentially we're going to use, let's put this up here. We're going to use y equals mx plus b, slope-intercept form, for both. At least that's how I'm going to do it. Let's color code make the first one green. So here, to get y by itself, we got to subtract x from both sides. So then that would turn into -y less than -x plus 8. Then we've got to divide by -1. So we divide everything. And remember, anytime we multiply or divide by negative, the inequality sign flips its direction. So it becomes y is now greater than positive x minus 8. So let's go right to the graph. We've got a b value of -8, which puts us right here. And then the n value is 1 over 1. It's a positive 1 over 1 because there's an invisible 1 in front of that x. So we just go up 1, right 1. So I'm going to go up 1, right 1 as many times as we can. And then to make it a line in the opposite direction, we're going to go down 1 and left 1. Just reverse it. Let's see. It's not or equal to, so it's a dotted line. It sort of already looks like a dotted line. I guess I will dot it, though, just for the sake of completion. And shading. Y is greater than, Y is bigger than the other side. So since Y is bigger, we shade above. I'm not going to shade the whole graph right now. I'm just going to shade that to signify that it's above the green line. Now let's do the red. All right, the red, here we have to subtract 3x from both sides. So that becomes, let me scroll down slightly. We get y is less than or equal to -3x plus 6. And we're all done with that one. Y is by itself. We don't have to divide at all. So now we go straight to our graph. So we go up to 6 for our b value, our y-intercept. And then it's -3 over 1. So it's down 3, right 1. 1, 2, 3, and right 1. We're going to do that as many times as we can. 1, 2, 3, 1, 1, 2, 3, 1, 2, 3, 1. Oh, that one shouldn't be there. Scroll down a little bit. Get my face out of the way. 1. And it's got to be a line. So in the other direction, we go up 3, 1, 2, 3, and left 1. This is or equal to, so this is going to be a solid line. Let's see if I can make a sort of straight solid line. It's not going to be perfect, but we've got all the important points there. Got to move my face again. There's that. Okay. Now we have to worry about shading. Y is less than, Y is smaller, so we shade below. So I'm going to shade below this red line. I seem to not be able to get the whole graph on the screen at once. All right, so the solution set is going to be where it's shaded red and green. So that's above the green line and below the red line. So essentially our solution set is going to be all this part of the graph. That's where the solutions will be. And if we check that against our answer, let's see. Yeah, that looks pretty close. Yep, looks good to me. All right, let's take a look at number 8. Same thing, graphing. First thing for the green, got to figure out if it's a line or an AV. There's no absolute values, so it's going to be a line. Remember, at this point in our mathematical careers, those are the only two we're dealing with, lines or V's. We'll get to other different shapes later. So got to get y by itself, divide by 6 everywhere. And the green becomes, let's see, that's y is greater than or equal to 1/3 x. Oh, that should be dividing by that. Ooh. That's kind of ugly. I guess we can deal with that, though. So that's going to be plus, let's simplify that. So that's 4/3. Ugh, that's kind of disgusting. Did I do that correctly? Oh, I did. I was kind of hoping I made a mistake. All right, so we can deal with that, though. So the y value is, the y-intercept is 4/3. So let's think. That's going to be like 1 1/3. So let's go 1 and up 1/3. Maybe it's about there. This graph isn't going to be perfect, but it's okay. So then we've got to look at our slope. So it's up 1, right 3. So I go up 1, which puts me like there. And then I've got to go over 1, 2, 3. Hopefully that's coming across on the video. So we're right there. Then up 1 and right 1, 2, 3. One more time. 1, 2, 3. And that's as far as we can go. In the opposite direction, we go down 1 and left 3. So if I go down 1, that puts us right there. Then left 1, 2, 3. Down 1. Left 1, 2, 3, down 1, left 1, 2, 3. This will be a solid line because it's or equal to, so there's a solid line. And shading, we have to shade above. Y is bigger, Y is greater than, so we shade above. So we just put a small amount of shading right now. We'll fill it in later once we have our final answer. All right, now this next one I like a whole lot because it's just x is greater than 4. So since there's only one variable, it's going to be a vertical or horizontal line. So let's figure this out. So it's x and a 4. So let's go to 4 on the x-axis. And then remember, whenever we're doing a vertical or horizontal line, we cut across the axis we're on. If we're on the x-axis, we cut it vertically. So we're going to need a vertical line, which will be dotted because it's not or equal to. It's just, I forget if it's less than or greater than, but it's not or equal to, which makes it a dotted line. And now for the shading, it's x is greater than. Now this is the one time where we don't think above or below. When it's a vertical line, that's the one time we have to think left or right. For any other line, make sure you're always thinking above or below. But I mean, it sort of makes sense because with a vertical line, there's no above or below. So now we have to think left or right. So if we're thinking bigger than x, if x, or rather, if x is bigger than our number, if we think x being bigger, do we think left or right? Well, I think right, because that's where the bigger numbers are. Like moving to the right, that's how we get bigger. Moving to the right, it's like, okay, 5, 6, 7, 8, 9, those numbers are getting bigger. So we're shading to the right of the red and above the green. So where will our solution set be? Looks like we're going to be right there. That's where the shading will double, or overlap rather. Let's compare that to our answers. That looks pretty good. Yep, looks about that. Okay, excellent. 3 more to go, looks like. All right, so now let's see. Still graphing. This first one, which is green, it's going to be a line because there's no absolute values. Really, it's just y is less than -2. So we're going to go to -2 on the y-axis, cut across the axis, which will make it horizontal. Dotted line because it's not or equal to. That's terrible. You'd figure a teacher would be able to make a straight line, but here we are. Shade above or below. Let's think y is smaller, y is less than, so we shade below this green line. All right. Now the second one in red. Okay, we see an absolute value. So this means it's going to be a v. It's going to be a v. So now we have to remember our vertex form, which is a times the absolute value of x minus h plus k. First thing we have to find is the vertex. The vertex is, let's see, let's remember the vertex is always hk, which is important because, let's do this in blue. The h in our formula is a negative, but it comes out as a positive. So that means whatever sign it looks like h has, we have to change it. So let's see, what does it look like h is in our original? It looks like it's a +4, so it comes out as a -4. Now we only have to do that for h. K stays as it is. It's a +1, so it comes out as a +1. So the vertex is -4, 1. So -4 and up 1 right there. Since that's the vertex, I'm going to circle it in a different color just to highlight that that is the most important point on this absolute value function, or absolute value inequality, I guess I should say. All right, now it's time for our a value, which is sort of like slope. It's not exactly like it, but it's very similar. Our a value is just a negative in front of the absolute value. So we know that that's an invisible -1 there. So we can treat it like a -1 over 1. So our rise over 1 would be down 1, right 1. So down 1, right 1, and we do this as many times as we can. Move my face. There we go. All right, now here's where it gets different from slope, because in the other direction, if this were slope, we would go up 1, left 1. We would reverse it. But remember, this is an absolute value, so it's not going to be a line. It's going to be a v, I'm sure we're all saying at home with me. So to make this a v from the vertex, we still go down 1, but now we have to go left 1 after that. So we're only reversing the vertical direction. Oh, no, excuse me. Yeah. No. Yeah, we're only reversing the... I don't care. Just make it a v, okay? This video is already taken too long. All right. And then solid or dotted? I don't even remember. Dotted. And let's check the shading. Y is greater than, so we shade above the v. So our solution set is going to be anything, any spot on this graph that is above the red and below the green. So let's do that in blue. So that's this section right here and this section right here. So there's actually 2 sections that have double shading. So let's check this against our answer key. That looks pretty good to me. Yep. Okay, good. 2 more. Let's see if we can get this done. Again, we're graphing, so we'll do this in green and red, just like we've been doing all video long. So the green, we see absolute values, which means it's going to be a v. So now, oh, I see a problem here. We've got a coefficient that's not 1 in front of the x. So here we've got some algebra to do. I'm actually going to rewrite this. Y is greater than or equal to absolute value of 3x plus 15 minus 2. Because remember, this coefficient must be 1 for this to work. So for that, of course, it all disappears. Let me just erase that and fix it. To get rid of that 3, we have to divide not just this by 3, but every term we see inside the absolute value. Essentially, we're dividing out a GCF of 3. So we get y is greater than or equal to, let me scroll this graph down actually. Where was I? So we get an absolute value of 3 times x plus 5. Do not forget to put this 3 here. Right? That 3 is really important. You can't forget about the GCF. We're dividing it out in front. Let's bring down the absolute value and minus 2. Now, since we have multiplication right there inside the absolute value, we can split this up. Now, some of you have been skipping this step in your work, which is cool. I'm going to show my work on the board, though. It becomes absolute value of 3 times the absolute value of x plus 5, just writing the one absolute value as two separate absolute values. Then we subtract 2, and, well, the absolute value of 3, we know that that's just 3. So y is greater than or equal to 3 times the absolute value of x plus 5 minus 2. Need a little bit more space. Now that x finally has a coefficient of 1, we can go straight to our vertex form, or rather, it's finally written in vertex form. So that means we just find our vertex. Vertex is h and k. It looks like h is a positive 5, so that comes out as a negative 5. And k is a negative 2, comes out as a negative 2. So negative 5, negative 2. Let's see. So negative 5 and negative 2. There's that. Then our a value is 3, so that's like a 3 over 1. Oh, I forgot to circle the vertex to highlight it. That's going to be the point of our v, so it's up 3 over 1. So up 1, 2, 3, write 1, 1, 2, 3 over 1. We do that as many times as we can. And then we do it in the opposite direction in the other direction. So essentially we're flipping the horizontal direction. Still up 3 and left 1. 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. Let's take a look. It's or equal to, so it's a solid line. And shading, its y is greater than, right there, so we shade above. So we're shading above our v. Let's do the red. So the red, I'm actually going to have to rewrite this. So its y is less than or equal to 1/2 x minus 1. Now, this was actually kind of nice of whoever made this review because we had to do a whole bunch of work with the green, the first one, but this red one, it's a line because there's no absolute value and it's already in slope-intercept form. Our b value is negative 1, which is right there, and our slope is 1 over 2, up 1 over 2, up 1 over 2, 1 over 2, 1 over 2, blah, blah, blah. I guess I should be saying up 1, right 2. Then it's a line, so we flip both in the opposite direction. Down 1, left 2, down 1, left 2, keep going, keep going, keep going. It's or equal to, so it's a solid line. And its y is less than, so we shade below. And now our solution set is going to be wherever the shading overlaps, but the shading never overlaps for this graph. It's above the green and below the red, so it never overlaps, which means it's no solution. And that's exactly what we see here. And I think the graph looks pretty similar as well. Yep, looks good. Okay, now let's take a look at number 11. Write a system of inequalities to represent the following graph. So here we're going in reverse. Instead of having to come up with a graph for the system, they're giving us the graph, and we have to write the system. To make this a little bit easier to follow, I'll put some letters here. So A, B, C, and D, just so you can sort of follow which line I'm talking about. I know which ones I would start with. So I guess let's figure out how many we're going to need. So I see 1, 2, 3, 4 lines. So that means we need 4 inequalities for this system. I would start with either AB or with DC. The reason I would start with them is because they're horizontal lines. So it's just going to be y is greater than or equal to something. And we know that because both of them are going to be hitting the y-axis. I guess it's kind of tough to see, but if we imagine the green one extending, it would hit the y-axis right there. So the blue would be y, let's see, it's shaded below the blue line. It's shaded below the blue line, AB that is. So it's less than or equal to, since it's a solid line, not a dotted line. And what's the number? Let's see. If we start from the origin, go up, that's 1. So its y is less than or equal to 1. All right, 1 down, 3 to go. Now let's go to our other horizontal line, DC. So let's see, it's going to be y, and this time it's shaded above. The shading is above our horizontal line, so its y is greater than, still or equal to, because it's a solid line, and let's make that look a little bit better. And our number, let's see, start at the origin, negative 1, 2, 3, negative 4. So y is greater than or equal to negative 4. 2 down, 2 to go. Now we've got AD or BC. So these are not horizontal. So here we're going to need to find the slope and all that stuff. I would personally start with AD. The reason I would start with AD is because I don't like the way that looks. Anyways, the reason I would start with AD is because it's clearer what the y-intercept is. We can see the y-intercept right there. Now every line, not every line, I guess vertical lines don't have a y-intercept, but every line that's not vertical will have a y-intercept. So like even BC, which I'll do in whatever color that is, even BC has a y-intercept. It's just not as easy to see right now. That's why I would prefer to start with AD. So since we can see the y-intercept, we can use y equals mx plus b. All right, let's take a look. Well, we can find b. Well, actually, first let's do the inequality. So it's shaded above this line, so that means it's going to be, one more, it's going to be greater than or equal to, because it's still a solid line. Now, let's find the y-intercept. So the y-intercept is 1, 2, negative 3. That's where our line crosses the y-axis. And for the slope, let's see. I guess that's a good point. Point D, go from the y-intercept there. So it's down 1 and right 1. So it's a negative 1 over 1 for our rise over run. So, I mean, well, negative 1 over 1, that's equal to negative 1. But I don't even need to put like a negative 1x because that's the exact same thing as a negative x. Now, if you put negative 1x, that would still be correct. But don't tell the other math teachers this, but I'm kind of lazy. So as a lazy individual, if I can write less, I'm going to write less. All right, now we just have to do BC, which is going to be a little bit more work, unfortunately, because we cannot see the y-intercept. We know it's there, we just can't see it. And it looks like it's going to be way, way off the graph based on how steep this line is. So let's get that C back there. What was I saying? Right, since we can't see the y-intercept, we can't use y equals mx plus b. I guess we could, but I don't know if it's going to be the best choice. It's possible to use that form, but I think we'd be much better off, and I'm going to do this work down here, it'd be much better off using point slope form. Y minus y1 equals m times x minus x1. Because for point slope form, we still need the slope, but we can find the slope. And instead of the y-intercept, we need any point. So we just have to pick any point, even if it's not touching the y-axis. All right, let's find the slope first. So I'm going to go, tell you what, I'm not feeling creative. I'm just going to go from C to B. So that's a 1, 2, 3, 4, 5 over 1. So that becomes 5 over 1. We'll put that here, I guess. So that's just 1. Excuse me, that's just 5. My bad. So our slope is 5. Now to finish this, we need a point. I'll pick point C, I guess. It doesn't make a difference. You could pick point B and get the same answer. At least you're saying final answer. But I'm going to pick point C, which is, what are my coordinates here? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. And negative 1, 2, 3, 4. Negative 4. I'm going to double check myself one more time. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Awesome. Okay. Tell you what, I'm going to write that. I guess I can keep them both on the screen at the same time. Yeah, there we go. Now we're going to take that x and y, those coordinates, and plug them in for x1 and y1. So it becomes y minus, we could put minus a negative 4, but I really don't like double signs. Minus a negative just becomes a plus. So it's y plus 4 equals 5 times x minus 8. Now to make this an inequality, because we know we're going to have to change that equal sign at some point, I want to get y by itself. Really? That all went away? How annoying. Let's just, killing me. Whatever. Let's just redo it. What was it? X minus 8? Okay, we got to get y by itself was the point. So we're going to, let's distribute first. So y plus 4 equals, that does not look like a plus, 5x minus 40. Then we subtract 4 on both sides and end up with y. Let's do our inequality now because y is by itself finally. For this, it's shaded above that. So that's going to be a greater than or equal to since it's a solid line. And the right side is 5x minus 44. So let's rewrite that up here so we can check our answer. So it's y is greater than or equal to, what was it, 5x minus 44. Let me double check that one more time. I'm not sure if I remembered it perfectly. 5x minus 44. Yep, 5x minus 44. Let's check the answer. So we've got y is, I guess we'll do this in yellow. I'm running out of colors here. Y is less than or equal to 1. That one's good. Y is greater than or equal to negative 4. This one's good. Greater than or equal to negative x minus 3. Good. And greater than or equal to 5x minus 44. Excellent. So there you go. Hopefully that was helpful. If you have any questions, let me know. Enjoy the rest of your day. I'll see you all tomorrow.